So let's look at configuring a router on a stick for Inter-VLAN routing. That's our second approach that we can take for it. So we're going to give ourselves a router here. And here we go. And again, I'm just going to configure the router interfaces. Now, this is going to run a little bit differently. In traditional Inter-VLAN routing, we ran separate lines between the router and the switch to access ports on the switch in each appropriate VLAN. For a router on a stick, we only run one connection from the router to the switch. But we configure it as a trunk line on the switch, and then we've got to do some special configurations on the router. So let's start out with a switch here. I have interface G01 already set up as a trunk line. So let me do the same thing for G02. So I'm going to go interface G02. Let me go to config T first. Interface G02, switch port mode, trunk, switch port, trunk, native, VLAN 99. And the other thing I want to do is switch port, no negotiate. And you'll see that option. Let's see. That's not what I wanted. Whoops. Switch port. No negotiate. There we go. Helps when you type out the entire thing. No negotiate right here. The device will not engage in a negotiation protocol. In other words, it turns off DTP. Now, since we're not going to be connecting to another Cisco switch, we're not going to be using DTP. We're connecting to a Cisco router. So we might as well just turn it off. So switch port, no negotiate. Now, if I end out of here, let me look at my configuration on G02. Switch port trunk native VLAN 99, switch port mode trunk, switch port no negotiate. Perfect. All right. Then we're going to run a single connection from our switch on our new trunk line, so G01, or G02 rather, to our router G00. And then I've got a couple of different configurations I need to do on my router. I'm only going to worry about that interface config, not everything else. We've seen everything else in other videos. So go to our global config, interface G00. Now, I don't set an IP address or anything like that on this interface. What I do is I issue a no shutdown because I need to activate the interface. And then I can set a description if I want. Trunk line for Inter-VLAN routing. Okay, then what I'm going to do is I'm going to create a sub interface. And basically a sub interface is a software interface that's associated with an actual physical interface. So it would be this, interface G00.10. And I'm doing that, I'm making the dot is what makes it a sub interface. I'm doing the .10 to make it sub interface .10 is my identifier. Now that doesn't have to match my VLAN ID, but if I do, it simplifies my life, so I'm going to do it. So that gives me my sub interface. Now I need to set the encapsulation. So it's encapsulation .1Q. Remember when we were talking about trunk lining? Making trunk lines, we talked about the 802.1Q protocol. Well, this tells us to use encapsulation or use that protocol, the .1Q protocol. And then I'm going to specify which VLAN ID I want this to handle. So this is going to handle everything that's encapsulated for with .1Q and identified as VLAN 10. Then I'm going to set the IP address 192.168.1.1. All right, I don't have to do a no shutdown because you don't shut down or no shutdown sub interfaces. You do that on the physical interface. So let me create another interface. Interface G00.20 encapsulation .1Q20 IP address 192.168.2.1. Let's do another IP, interface G00.30. And we're doing that G00, so it identifies the sub interface with that physical interface, obviously. and encapsulation.1q30. Set the IP address 192.168.3.1. Now, that's what we were able to do before with our legacy Inter-VLAN routing, where we could only do 3 VLANs because we only had 3 physical interfaces. Well, now I've put 3 logical interfaces or sub-interfaces on a single physical interface. But I'm not limited to that. I can do more. In fact, I can do about as many as I want. So I'm going to create a new one, interface G00.99, and this will be for my native. So my command is going to be a little bit different to identify this one as a native VLAN. It's encapsulation.1q99, and all that's the same. And then I just add the keyword native, and that says, hey, this is going to be the native VLAN for the trunk line you're connecting to. Set my IP address 192.168.1.99.1. Forgot my subnet mask. There we go. All right, now let's end out and let's do a show run. And here we'll see our configurations. G00, we have a description. No IP address, we're not using it. All IP addressing is going to be handled by my sub-interfaces. .10, .20, .30, .99. And for each one of those, I have an encapsulation that identifies it with the correct VLAN ID, and then has an IP address in that VLAN. Now, one of the things you got to watch out for here when you're doing your configuration and troubleshooting, make sure that you have the right VLANs identified. Make sure you have IP addresses, the right addresses for the right VLANs. It's actually easier than troubleshooting legacy Inter-VLAN routing that we talked about in a previous video. In that one of the things you got to watch out for is make sure you've got your connections plugged into the right interfaces on both the router and the switch. It's actually a very common problem with traditional Inter-VLAN routing and trying to troubleshoot it. Let me do a show IP interface brief so you can see how we're configured here. G00 and then all of my sub interfaces with my IP addresses. And I only did the no shutdown on this interface, but because of that, all of these are up as well. Okay, now let's see if it works. Let's go to, this time let's go to this PC, 3.10. Go to our command prompt, and let's do some pinging outside of our VLAN. So let's ping 192.168.1.11. Again, we're going to have to wait for some art because we're dealing with packet tracer. And there we go. We are replying. If I trace route this, 192.168.1.11, you'll see that it goes to my default gateway, 3.1, and then to my 1.11 interface, or my 1.11 PC. So what's happening here is we're going up to the switch. The switch is sending it out the trunk line to the router. The router picks it up on the appropriate sub-interface, routes it, sends it back down coming from the appropriate sub-interface. It's then tagged as it crosses here, the trunk line to switch 2, which then sends it out to a port in the appropriate VLAN. Okay, so that's the way that the router on a stick works. Is there a drawback to a router on a stick configuration? Yeah, actually there's one big one. And that is we only have one link here. Which means if we have a lot of Inter-VLAN routing going on, this one link may end up being a choke point for our network. May end up being a bottleneck. So that's the big drawback, one of the big drawbacks to a router on a stick. The advantages of a router on a stick are that it's far more flexible, and we don't have to use as many ports, and we don't have to have as much, or we don't have as much possibility of wires getting crossed as we do with legacy or traditional Inter-VLAN routing. So it is a big step up from there, but it does have a couple of drawbacks on its own. There is one other factor that comes into play with this, and that is You are offloading to another router, and odds are that router is going to have other operations. So you may be connecting to remote sites or something like that. So we're just adding another layer of routing to that router. And depending on your network and your traffic flow, that may or may not be an issue. Now, I do want to address one more thing real quick, and that is, let me try to ping one of my switches. Remember, I don't have any ports in my management VLAN 99, and we talked about this when we set it up in the video on configuring VLANs, access ports, and trunk lines. So if I try to ping 192.168.99.2, which would be this switch, I'm going to get timeouts. And it's because even though this one has a route to get there, this one doesn't have a route. The switches don't have a route back. And that's because when we configured our switches, we didn't add a default route. So let me Control C, go to config T, and I'm going to issue the command IP default. The whole command is IP default dash route, but I'm going to do IP def 192.168.99.1, and that will set my default route. Copy, run, start. And I'm going to do the same thing over here for this switch. Config T, IP, default route 192.168.99.1. And copy, run, start. Okay, now I should be able to, from my PC, ping my switches. Remember, switches, it takes them a second longer to resolve ARP, but there we go. We can now ping 99.2 and 99.3. All right, so this is a router on a stick Inter-VLAN routing configuration. We wait for 99.3 to reply. There we go. All right, so this is a router on a stick Inter-VLAN routing configuration. It's better than legacy Inter-VLAN routing, but there still is that one major drawback, two major drawbacks. We're putting extra processing on here. That may be a problem. If we're doing a bunch of routing, we may flood this line. That may be a problem. There is one other solution that is incredibly efficient. It may cost a little bit more, but it's very efficient and works very well, and that is Inter-VLAN routing via a layer 3 switch. And that's what we're going to talk about in our next video.